Dzień dobry, witam wszystkich serdecznie. Poprosiłbym o potwierdzenie na czacie, że nas słychać i widać i będziemy za sekundkę zaczynać część właściwą. Super, bardzo dziękuję za potwierdzenie. Jest mi niezmiernie miło powitać Państwa na kolejnym webinarium organizowanym przez firmę Dilectro, tym razem we współpracy z jednym z naszych vendorów, z firmą Blueye, odpowiedzialną za produkcję norweskich dronów podwodnych ROV. Dzisiejszy webinar ma charakter praktyczny, podzielony będzie on na 3 części. Pierwszą część robimy sobie teraz takie miękkie wprowadzenie. Druga część będzie to właściwa prezentacja odnośnie firmy i rozwiązań, w tym najnowszych dronów, które zostały zaprezentowane w maju tego roku, czyli modeli X3 Ultra oraz zupełnie nowego X7. Po tej części zostanie przeprowadzony pokaz na żywo sportu w Trondheim, którego my będziemy mogli obserwować za pośrednictwem połączenia Microsoft Teams, czyli tej natywnej integracji po API z ekosystemem Microsoftu. Ja nazywam się Daniel Olszewski, w firmie Dilectro odpowiadam za kwestie operacyjne. Ze mną jest Maciek Chmielewski.
Witam serdecznie.
Maćku, czym się zajmujesz?
Ja tutaj jestem odpowiedzialny za drony podwodne u nas w firmie i mam nadzieję, że dzisiejsze spotkanie rozjaśni tutaj troszeczkę tematykę i odpowie Państwu na wszystkie pytania.
Z takich kwestii jeszcze organizacyjnych ja tylko dopowiem, że webinarium jest nagrywane. One później będzie dostępne zarówno na naszej stronie internetowej, jak i na naszym profilu na YouTubie. Część prowadzona przez firmę Blueye odbędzie się, tak jak komunikowaliśmy, w języku angielskim. Ja będę raz na jakiś czas tłumaczył większość rzeczy, które będą prezentowane po angielsku, tak abyście Państwo też mieli pewność, jakby był jakiś problem ze zrozumieniem. Na końcu przewidziana jest też sesja pytań i odpowiedzi łącznie z przedstawicielami producenta, więc jest to bardzo dobry moment na te wszystkie szczegółowe, techniczne, mocno merytoryczne pytania. Całe spotkanie powinno potrwać około 60 minut, z czego 20-25 to będzie część teoretyczna, a pół godziny ta część praktyczna. Z mojej strony wszystko, oddaję głos do Ody. Oda, floor is yours. You can start the presenting.
All right. Thank you, Daniel. And thank you, Dilectro, for having us here today. I'll share my screen then. All right. Do you see the beginning of my presentation here?
Yes,
Perfect. You can probably also highlight my screen if you wanted to blow up on the screen to people as well.
Okay.
Yeah. So hi, everyone. My name is Oda Riggen. I'm the Chief Commercial Officer here at Blueye Robotics. With me today, I also have Petter Sjursen. He's a product engineer with us, and he will also do a live demonstration of the Blueye X3 Ultra later on. I thought I should start with a company introduction. I think Daniel already maybe said something about us, but I don't understand Polish, so I'll do an introduction as well. I'll also run you through our ROV models and a lineup that we currently have. I'll tap into the Blueye Cloud as well, which is new software that we recently launched for all of our ROV clients. And we're going to end with the live demonstration by Petter Sjursen as well. So first, who is Blueye Robotics? Well, we are a Norwegian company. We're a spin-off from the Center for Autonomous Marine Operations and Systems at the university here called NTNU. We're about 20 international experts here in all kinds of fields. And the mission that we have is to create the most user-friendly and reliable underwater technology to give people and organizations a frictionless access to view what's below the surface. We do all of the development, service, testing, production, supporting everything here from Norway as well. And since we started selling these ROVs back in late 2018, we have supplied over 1,350 of these systems across over 65 different countries as well.
Okay, so I will do. Could you please just forward? Backwards, sorry for a couple of seconds. Ja Państwu trochę tylko powiem, żeby nam nic nie umknęło. Firma ogólnie posiada swoją siedzibę w Trondheim w Norwegii, stamtąd się wywodzi. Jest to właśnie, tak jak Oda powiedziała, spin-off projektu uniwersyteckiego na Uniwersytecie w Trondheim. Firma stale się rozrasta i liczy już ponad 20 ekspertów, którzy zajmują się projektowaniem stricte tego rozwiązania, które jest de facto rozwiązaniem ekosystemowym, bo bazuje nie tylko na samym sprzęcie, ale też na całym oprogramowaniu, o którym się za chwilę też więcej dowiemy. Całość produkcji, testowania, wytwarzania, wsparcia odbywa się właśnie w siedzibie w Trondheim w Norwegii. No i od momentu powstania firmy dostarczyli już 1350 systemów ponad do 65 krajów. Są to kraje w Europie, ale też nie tylko. Okay.
So our target customers, they are professionals that benefit from doing frequent underwater inspections, and they're typically not very well known to ROV systems. They're not experienced ROV pilots, and they choose these systems because they are one-person portable. They are multi-capable as well of doing all kinds of different tasks below the surface. They're super robust. And they're very user-friendly with an app-based operating systems as well. So now I'm going to move over to the lineup as well. So we recently launched a new lineup here in May, where we introduced a completely new Blueye ROV called the Blueye X7, and then we did some major updates to the existing X3 as well. I'm going to start with the X7, which is a completely new model. It is more powerful. It can carry more payloads. You can use dual batteries or topside power with it. It also has a NVIDIA brain as well, capable of doing AI and computer vision tasks. It has 7 thrusters and it has 7 degrees of freedom, so you can operate it in all the directions as well. That's a difference from our other ROV models as well. There's a major upgrade to the camera. Now we have a 4K camera as well, capable with zoom as well. You can dive down to 500 meters. And you can also add removable storage to this, meaning that you can store all of your media files on a USB stick that you can easily take out of the ROV as well and quickly get the media files over to your computer, for example.
Okej, so przechodząc ponownie na naszą polszczyznę, X7 jest zupełnie nową konstrukcją, która jest aktualizacją tak naprawdę modelu, znaczy modelem X3 na sterydach, bo model X3 został zaktualizowany do wersji Ultra, a X7 jest zupełnie nową konstrukcją. To, co jest najważniejszą zmianą, po pierwsze mamy konfigurację z 2 bateriami, z tym możliwością umieszczenia baterii na szczycie drona. Dodatkowo mamy 7 silników, 7 portów do podłączenia różnych modułów typu sonar, lidar, chwytak. Mamy wbudowany komputer AI-owy NVIDIA Jetson NX i to jest sztuczna inteligencja, która odbywa się tylko i wyłącznie bezpośrednio brzegowo na urządzeniu, czyli nic nie musimy wysyłać do chmury. Ten procesor odpowiada między innymi za tryb mętnej wody, który jest nowością tutaj w tych kamerach zastosowanych w tym dronie, czyli w kamerze, która już teraz jest 4K, a nie Full HD. No i względem X3 tak naprawdę mamy 500 metrów głębokości, więc jeszcze głębiej. No i mamy możliwość implementacji wymiennej pamięci masowej, czyli łatwo możemy wpiąć się w portem USB. Nie mamy tylko i wyłącznie tej wbudowanej pamięci NAND w dronie. Maćku, czy coś jeszcze byś chciał dodać?
Chyba wszystko wyczerpałeś.
Okay, Oda, thank you. You can continue.
So the X7, it has 7 ports to connect to external equipment. As you can see on the model in the center here, it is a multi-beam sonar that is highly integrated to the model. But there are also options of adding UT sensors. You can have a grabber, environmental sensors. You can have extra cameras. You can put on a USBL or other positioning systems as well, because it can fit in total 7 systems as well to it. So this is a workhorse to do more tasks below the surface. It can handle currents probably up to 3 knots. with its 7 thrusters and dive down to 500 meters. So this model is for more type of offshore clients or those doing a lot of more complex tasks below the surface, but it's still quite compact also in terms of portability and weight. It weighs about 20 kilos, so you can actually still bring it along on airplanes as well if you're traveling with it. And you can still be one person operating it as well. I'm going to show you some different configurations as well. This illustration is of the Blueye X1 that has a USBL on top there. It has a multi-beam sonar and it has a reach alpha grabber. Here you can see the Blueye stereo system connected to it as well, together with the DVL, which doesn't show here, but it's on the underside of the ROV and together with the sonar as well. And here's also the Viper MDS system as well, if for mine disposal as well, together with multi-beam sonar, DVL, positioning systems as well. So there's multiple configurations available for this model. Moving over to the X3 Ultra, unless you want to translate something, Daniel, first.
Okej. Więc tak jak Państwo widzieli, X7 ma aż 7 możliwości podłączenia różnych rzeczy. No i tutaj zaprezentowane zostały takie najpopularniejsze tak naprawdę konfiguracje, które Blueye proponuje, żeby zmaksymalizować możliwość wykorzystania tego drona.
Tak, modułów jest bardzo dużo tutaj zaprezentowanych, zostało tylko kilka jako przykład, ale jeżeli chcieliby Państwo też poznać różne inne rozwiązania, to bardzo prosimy też zostawić na wiadomość. Wtedy bardzo chętnie po prezentacji przygotujemy taką wycenę czy prezentację tych wszystkich różnych podzespołów, które są dostępne.
Okay, Oda, you can move on.
So moving over to the X3 Ultra. So we already have the X3 in the lineup, but now we did some really nice upgrades to it. And the major things that we upgraded was the brain, for example. So now it's outfitted with a NVIDIA chip. So now you can run AI and computer vision tasks with the X3 Ultra. It also has a major upgrade to the camera. Now it has a 4K camera with zoom. And this model is, you can go down to 300 meters depth. It can carry one battery of up to 5 hours. It's fully certified and it's self-serviceable as well. It's also one-person portable. You can see it in the back of Daniel's head as well.
Yes.
So that is a true size of it. It has 4 thrusters. It can run in up to max 2.5 knots of current as well. So that's a very portable system and very easy to use. It runs on the same app-based system as the X7, etc. as well, which Petter will show you more later on. But kind of diving into the more interesting parts and the new stuff with the X3 Ultra and the NVIDIA chip is that you can do more computer vision tasks and AI tasks. You can run it directly on the drone. You can use computer vision to detect different objects or track different objects. You can do that both on video and sonar data. You can run collision avoidance. You can do more like complex autonomous missions with it. It will provide you with depth perception as well, so you can keep like a fixed distance to a wall, for example. It has possibility for SLAM, and you can do more real-time video enhancements as well, such as the turbidity filter that Petter also will show you. So and then it also opens up to bringing your own model as well to run on the system. So some scenarios here that you can use these AI models for is to detect holes in fish pens. So that's relevant for aquaculture, for example. You can detect different underwater mines, detect underwater infrastructure, look at different marine species, or you can train a model to detect missing persons, for example, or you can classify different marine fouling, for example, or damages to ship hulls. So here's just fantasy that setting limitations as well. So we have been testing this a bit as well. So here's one example of object detection. So obviously we have a lot of data on filming ROVs, the Blueye ROVs. So this image gives you an example of how we can detect different Blueye ROVs in the water. And you can also do that with tracking. So we've also done that for the ROVs, but for clients, they can train their own models on objects of their interests. And here is one of our clients that has been doing this already for years. So this is Stein Maritime Consulting. He's doing a lot of ship hull inspections, and he's using AI to detect different types of fouling, but also different degrees of damages to a ship hull as well, which is super interesting and very relevant for ship owners. Here's an example of the turbidity filter. So Petty will show you this live as well, but it's a computer vision possibility for the Blueye X3 Ultra, and the X7 obviously is super, super interesting.
Okay, can you just go back to X3 Ultra? I will do some kinds of the follow-ups. Więc drodzy Państwo, Blueye X3 Ultra tak naprawdę jest dosłownie tym samym dronem, który Państwo już znacie od 2 lat ponad. Jest to model, który został zaktualizowany. Ta aktualizacja oczywiście odbyła się, nie może być dzisiaj w dzisiejszych czasach prezentacji bez sztucznej inteligencji, bez AI, więc tym razem tak jest. Model X3 Ultra ma 2 największe zmiany. Pierwsza z nich to jest procesor właśnie Orion NX NVIDIA z 16 GB pamięci, który odpowiada za te wszystkie funkcje sztucznej inteligencji na urządzeniu, przetwarzane bezpośrednio w procesorze znajdującym się pod wodą. I to jest pierwsza zmiana. I druga zmiana jest to aktualizacja kamery. Wcześniej mieliśmy kamerę Full HD, teraz mamy kamerę 4K UHD, która właśnie ładnie współpracuje z tym Jetsonem Oryxem NX po to, żeby działał tryb mętnej wody. I tak jak Państwo widzieli, pokazanych było wiele przykładów wykorzystania mocy obliczeniowej jednostki NPU też zaszytej w dronie. Możemy wykorzystać wbudowane funkcje w ekosystemie Blueye'a, w systemie operacyjnym, który ciągle stale jest też aktualizowany i otrzymuje nowe funkcje, ale też jeżeli mamy specyficzne potrzeby i chcielibyśmy, możemy wytrenować własne modele językowe i je zaimplementować w dronie po to, żeby wykrywać na przykład specyficzne jakieś uszkodzenia, tak jak był pokazany przykład z inspekcją łodzi.
Dokładnie. No i tutaj na pewno dużą uwagę proszę skupić na dalszej prezentacji na trybie mętnej wody, bo widzieliśmy to na żywo i robi to naprawdę bardzo duże wrażenie, także proszę uważnie śledzić dalej.
Ja tylko jeszcze dopowiem, że pytania widzieliśmy, zostawiamy je na tą sesję Q&A, zbierzemy sobie wszystko, nie pozostaną bez odpowiedzi, także spokojnie na pewno się do nich odniesiemy. Jeżeli chodzi o X3 Ultra, dobrze warto też powiedzieć, że jest na tyle kompaktowy, co zresztą też Państwo widzieli, on waży 8,6 kg, jeżeli chodzi o tą jednostkę podwodną.
Tutaj baza się nie zmieniła z tym, co znamy od lat tak naprawdę.
Tak, i koledzy z Norwegii przylatują do Polski z tym dronem normalnie w bagażu rejestrowanym. Także są też dostępne 2 wersje akumulatorów. To jest bardzo specyficzny use case, ale jest poniżej 100 Wh, aby można było bezpiecznie transportować go normalnie regularnymi liniami lotniczymi. Okay, Oda, thank you. You can continue.
I will. All right. So last but not least is the X1 underwater drone as well. So this is our entry model ROV. It is of the same size as the X3 Ultra. It has a camera on a tilt. It's a full HD camera. you could dive it down to 300 meters. You can use the same type of battery, same type of operating system as the other models as well. So compared to the X3, this only has one guest port. So this is the ROV to go for if you only need the grabber or you're doing more light underwater tasks as well. But this is a very capable model as well, super robust and self-serviceable. You can use you swap out the thrusters and tether yourself, for example. So, and it runs on the same operating system as the other model. So this is a lot of value for the money, for sure.
Okej, czyli X1 jest dronem, który pozostał w ofercie bez tak naprawdę aktualizacji, czyli nie został zaktualizowany jak model X3 do wersji Ultra i nie jest nowym modelem X7. Jest to podstawowy taki entry level, który często jest też dronem wykorzystywanym na przykład do celów szkoleniowych bądź nauki pływania konstrukcjami ROV. Nadal posiada większość funkcji X3 Ultra. Największe ograniczenia tutaj to jest brak AI, brak kamery 4K z trybem mętnej wody i tylko jeden port na aktualizację na dodatkowe moduły.
Tak jest. No i tutaj ważną rzeczą do podkreślenia jest to, że moduły są kompatybilne, tak? Tutaj jeżeli chodzi o różne wersje urządzenia, także też posiadając ten model możemy do niego zaimplementować moduły z modelu wyższego i odwrotnie, także tutaj pełna współpraca i nie ma z tym problemu.
Okay, Oda, thank you.
Then I'll move over more to the software side. So in May, we also introduced the Blueye Cloud, which is a software to store all of your ROV data. So the highlights of it is that you get a full fleet management, you get a full overview of all of your ROVs and all of the equipment that you have, including all batteries and sensors, etc. You can upload all of your dives to the Blueye Cloud and you can see a playback of your dives. You can organize them in projects, which is very useful if you're working on a paid project for a client, for example, and you really want to combine all of the dives and combine all of the data and media files to show it to your client. And you can also share this securely with those stakeholders as well. Another thing that's very interesting is to do the mission planning in the Blueye Cloud. So you can plan your mission on your computer in a nice map, and then you can extract those files and push it directly to the Blueye app, and then start the Blueye to go on that mission. And you could also do live streaming, and there's some AI capabilities in here as well. And now I thought I'd give you a live view of the software as well. So I'm going to stop sharing this presentation and jump into a different window here. So stay with me a second. Let's see here. I'm going to find the right view here. Okay, so now you should be able to see my screen again.
Yes, it's okay.
Okay, perfect. So now I am logged into the Blueye organization in our Blueye Cloud. So obviously we have a large fleet of ROVs. So those are listed here. Those are the ones that we have tested now and used in the Blueye Cloud. So we have a lot of models here. We have tons of equipment. So you can see each of the equipment here. You can see all the dives that they've had. And the serial numbers and which drone it has been connected to, etc. And then you can see all of your media files here, for example. So this is just a list of all of the media files that you have. So you can store tons of media files here, both like videos and photos. But the more interesting part of the Blueye Cloud, which I think at least is the project model, which is a really nice place to stock kind of all of the different dives and media files related to one project. So if you're doing one inspection project for a client, you create one project and then you add all of the data points related to that project. So this is an example we did with Northern Wake Fire Department, because they were visiting us and doing training with us, and we also trained them in using the Blueye Cloud. So this is just the overview, so you get like first an introduction to what the project is all about. Here's a report below that has been created, and then you have different media files as well. And then you can have AI to help you write up that report as well. And then you can attach different dives that you've done, all of the media files here. You can have other attachments if you took some footage topside as well, for example. And you can have missions connected to it as well if you made any specific missions and had the ROV run to different points of interest, for example. So let's go into one of those dives. We can head into this one. And if we hit map here, it will render that actual dive in the map. And it has collected all of the different media files. And you have information about the dive here. You have information about the battery and equipment that was used on the dive itself. And you can see a playback of the dive here in the timeline here. So if I move this thing, you'll see here, for example, that, and I move this map, you can see the ROV here in white here. And if I start this, you should see, let's see, a multi-beam recording, if I can get that up and running. Maybe to be here. Yeah, so you can see the multi-beam recording appearing here during the dive. And you'll also see the ROV moving around when I'm dragging this here. You can see where the footage is taken. And since they also used the voice recording on the media files as well, you can see that it's already on the video here. So they capture everything you say during the dive. So if you are good at like talking while you're diving and explaining what is happening, you get that on the recording as well. And if you implement that to the Blueye Cloud, the AI will transcribe all of that and put that into a report. So it's super easy and fast to get a nice report out to your client in just like, I would say probably just 15 minutes, and it will be done, and it will look super professional like this. So this is a very, very helpful tool in order to report to clients. And another part of it is doing missions. So for example, yeah, me and Petter, we did a mission last week. We tested setting up a mission because we wanted to do an inspection here. So this is what you can do in the cloud. You can, for example, put up points of interest on a map like this and plan this. You can sit comfortably in your office, getting this down and tweaking it, and then you export it and upload it to the Blueye app, and then you hit start dive, and then the ROV will run those points of interest and the mission that you have planned as well. And when you sync that up to the cloud again, you'll have it here, and you will see the ROV do that mission as well and report on it. So this is a super helpful tool as well. And it's available at cloud.blueye.no. There's some examples there as well if you want to dive into it. Yeah. Then I think I've covered most of it. And the plan next is for Petter to move on and do his thing. But if you want to translate more, Daniel, this is a good time.
Okej, więc kończymy, drodzy Państwo, tą część taką powiedzmy teoretyczną. Teraz zaprezentowana została ta otoczka, oprogramowanie, jeżeli chodzi o nowość, czyli Blueye Cloud. I tak jak Państwo widzieli, mamy tutaj w jednym miejscu zgromadzony dashboard, naszą całą flotę dronów, łącznie ze śledzeniem zużycia elementów eksploatacyjnych, takich jak baterie. Możemy sobie tym wszystkim zarządzać, możemy w jednym miejscu utrzymywać wszystkie pliki i tutaj pewnie nasunie się zaraz pytanie, kto za to odpowiada, gdzie się te pliki znajdują i na jakiej infrastrukturze jest to przetrzymywane, więc jak nie trudno się pewnie domyśleć, jest to Microsoft Azure, w związku z tym, że Blueye bardzo blisko współpracuje z Microsoftem, jeżeli chodzi o integrację wszystkich rozwiązań swoich z ekosystemem MS365. Jest to w wyizolowanym Azurze w Europejskim Obszarze Gospodarczym, jest tutaj umowa zabezpieczenia danych, jest podpisana i RODO też jest zapewnione. Można tworzyć sobie nieograniczoną ilość kont, przypisywać do organizacji, mieć jedno konto duże w organizacji, mieć różnych użytkowników. Tak jak Państwo widzieli, można tworzyć misje, można też tworzyć projekty i raporty z misji. Podstawowa wersja chmury jest darmowa. Co oznacza podstawowa wersja? Mamy tam wtedy ograniczone miejsce na ilość danych w chmurze do przechowywania i ograniczoną ilość tokenów sztucznej inteligencji, która pozwala nam później robić te skrócone raporty, które widzieli Państwo w sekcji projekty. I myślę, że teraz możemy już przejść do tej części praktycznej i później do pytań i odpowiedzi. Okay, we can move on to the practical side of the presentation.
Very nice. I will open you guys up on a secondary camera here. All right, can you guys see me on the secondary device?
Yes, it's okay.
Perfect. All right. Yes, like Oda mentioned, my name is Petter. I'm a product engineer here at Blueye Robotics. And today we're going to do a little practical demonstration of the Blueye X3 Ultra. So a little bit of context about where I am today. I'm here in the harbor of Trondheim, Norway, where we have a little test office, which is really nice, gives us good access to the ocean here. And with me today, I have the Blueye X3 Ultra. And we have a really nice configuration of it today as well. In the front here, we have a gripper, lets us interact with the underwater environments. And here we have a sonar, so we can see, even if there's murky water, we can use that to navigate around and find objects underwater. On the bottom here, we have a DVL. I saw somebody had a question in the chat how we get position of the ROV underwater. And this is one of the tools we use to get that position. And we will talk a little bit more about that later. And on top here, we have a surface GPS. This does not work underwater. That's why we call it a surface GPS. So when the ROV resurfaces, it's come up and reaches the water line. This will go above it, and you will get a GPS signal, and you will have a really nice starting point. Some general info about the X3 model as well. Oda went through it a bit, but I will repeat a little bit of it and tell you guys a little bit more about how it works. We want this to be as easy to use as possible. And to do that, we have tried to simplify a lot of the operation of it. The ROV itself has 4 thrusters. It has 1 horizontal thruster, 1 vertical thruster, and then it has 2 push-pull thrusters on the back here. What that means is the ROV itself goes forward, backwards, it goes up and down in the water column, it can turn, and it can strafe sideways. The ROV itself doesn't pivot. And again, there's a very simple reason for that. We want this to be as easy to use as possible, so we built it to be mechanically stable. So when this is in the water, it will be in this direction or in this heading. It doesn't pivot. That makes it much easier to navigate when you're underwater, especially if there's little visibility and whatnot. We built it with the light stuff like the buoyancy in the top here, and the heavy stuff like the battery and the battery tube on the bottom. Of course, sometimes you want to look up and you want to look down. And to do this, we've implemented a tiltable camera. So with this camera, you can tilt it 30 degrees up and you can tilt it 30 degrees down. So this is the brand new camera that we've integrated into the Blueye X3 Ultra, which is 4K, has a really good dynamic range, which makes it much easier to see details and get clear images underwater. Underneath the main camera, we have the main work light here. This emits 3,300 lumens, which is more than enough for most scenarios. But if you need more light, you can also attach external lights to the ROV itself. ROV has an internal memory of 500 gigabytes. So when you record on the camera here, you can record it internally on the ROV. But of course, 4K video can take a lot of space. So we also have the option of attaching external storage to the ROV. And with that, it's just a memory stick that you pull out, and you can connect that to your computer and transfer the files really fast as well. On the backside of the ROV here, we have the tether. That is the tether connection to the ROV itself. This is twisted copper pair. It's not optical cable. And again, we want this to be as easy to use and as rugged as possible. So with having twisted copper pair, this will be really, really rugged. I will even use this to deploy the ROV to the water afterwards. So yes, the tether comes out on the backside here, and then it ends up on the cable reel right here. So right here, I have about 250 meters of cable. Our two most common lengths are 150 meters and 250 meters, but we can also do longer lengths if that is something you need. The breaking strength of the tether itself is 80 kilos. And again, the ROV itself is just about 10 kilos. So no problem using this to deploy the ROV in the water, or even using it to retrieve other objects that you grab onto with the ROV when it's underwater. In the middle of the cable reel here, we have the surface unit. So that is how I will get the signal from the ROV and connect it to the control unit that I'm using. So inside of here is a small, almost like a Wi-Fi router. It will send out, it will get the signal from the ROV, and it will send out a Wi-Fi signal. And I can connect that signal on a phone like this, and a normal controller, or a more ruggedized controller like this. Both are very good options. Or even a computer if you want to. This runs on its own battery. It's charged here. And this lets you have a really stable connection to the ROV, but at the same time, the operator can move about freely without actually being tethered to the cable reel here. And I think the next step is getting this in the water now. So if you want to translate something, Daniel, you can do that while I setting this out in the water.
Okej, czyli tak jak Państwo widzieli, tutaj na kilka pytań już zostało odpowiedzianych przy okazji. To, co jest istotne z tej perspektywy takiej użytkowej, to jest to, że możemy go za tą linkę swobodnie wyciągać, łącznie z tym, że możemy coś z tej wody, łącznie z tą linką i z tym dronem.
Zupełnie nie musimy się bać, że coś się stanie, coś się urwie. Po to jest specjalnie ta linka wzmocniona, także spokojnie, proszę się nie obawiać, że coś się z nią wydarzy po prostu.
No i tak jak Państwo też widzieli, mamy tutaj ten model X3 Ultra z kilkoma modułami, które są dołożone.
Tak, to są takie najpopularniejsze moduły, które są wykorzystywane no już w takich naprawdę przy poważnych inspekcjach, tak? I tak samo tutaj, jeżeli chodzi o długość liny, długość kabla, to tak jak powiedział, no mamy tutaj opcję 150 metrów, 250, ale jeżeli jest potrzeba, żeby było więcej tego kabla, to też spokojnie
teraz Państwo
zorganizowane.
widzą, jak za pomocą tego kabla przewodu został zrzucony tak naprawdę
tak.
do wody.
Dobrze, chyba tutaj możemy
zaczekać na prezentację.
tak.
Jak Państwo też widzicie, można sobie łatwo z drona wpuścić do wody i sterować z innego miejsca, gdzieś oddalonego kawałek od samego nadbrzeża.
Tak, no i też jak było widać, mamy dwa kontrolery do wyboru. jeden podstawowy, gdzie wkładamy telefon z aplikacją, i drugi taki kontroler typowo dronowy, można powiedzieć.
All right. Perfect. So I have the ROV in the water now. As you might have seen, it was quite easy to get it out. I just used the cable. I used the easy hand over hand motion when deploying it, and we got the ROV out here. If you can, of course, it is good to use the handle on top of the ROV to just deploy it. But of course, often we are in locations which don't let us get down to the water level, and then you can actually just use the cable like that. Makes it very simple to use. And we are already underwater here, and we have a good stream that shows us quite some nice details, even though we have quite a lot of sediments floating around in the water here today. It's no problem seeing what is around us here. If I go even deeper, it will probably clear up even more. So just go down here a little bit. And we get a lot of different information on the screen here as well. On the bottom right of the screen, you see 4 buttons, and these translate to the 4 buttons on the controller that you are diving on. So you can change the lighting here. You can start and stop recording, and now you can see which quality I am recording in. And you can also put on auto depth and auto heading. The auto depth, auto heading is something that comes with all our ROVs. It's using the internal depth sensor and the internal compass to keep the ROV in the same heading and at a certain depth, which is really nice, helps you move about without having much problems. So if I want to get close-ups of whatever is in front of me, I can just move closer here, and I can even turn on the lights, and I will get some of the color back even. So if you need to get some really good images of what is underwater, that is something you can do here. And if I feel like I can't physically move close enough, then I can also use the zoom function here and zoom in and get some really nice details about all of the marine life that is on the wall in front of me. And then I can zoom out again. And I can start moving around. I can see that there is a little bit of compression that's going on in the Teams meeting. And none of that is seen on the actual screen, which I'm operating on right now. So also something to keep in mind. Oh, my bad. Just the wrong button here. Here we go. Turn on auto depth, auto heading again, and we're back in business. We get some other information on the screen as well. On above the 4 buttons, we have a gradient here, which shows us which direction the camera is heading. So I can point that up, I can point that down. Here I can even see the gripper in front of the ROV. I can open and close that as much as I want. And I can tilt the camera up again. Above that, on the top line of the screen, we got a lot of information as well. We got the battery percentage of all of the units. We have the ROV, the surface unit, and the phone that I'm currently operating on. Temperature inside of the ROV, tilt of the multi-beam, tilt of the camera, what kind of positioning we have right now, and of course the serial number and date today. And then on the bottom left on the screen, we have the current depth. So we're at 8.2 meters depth, and we have 1 meter down to the seafloor. And the reason why we get that info on how far it is down to the seafloor is because we have the DVL on it, the Doppler velocity logger. That will read how far we are from the seafloor and also how we're moving compared to the seafloor. So it can calculate also where the ROV is moving. All right. And let's see here. So as you can see, we have quite some okay visibility here today, even though it is raining and we have a lot of algae in the water. But if I double press on the screen here, I actually get the turbidity filter on. And now it's only on 50% strength. So that is helping us a lot as well. If you point the camera down to the seafloor here, you can see when I turn this on and off, how big of a difference that does. So that is really nice, especially if when you're outside and you're driving on a smaller screen and it's a lot of sunlight, and it can be hard seeing the details in front of the ROV. So with the turbidity filter here, it makes it a lot easier to navigate around, and especially in turbid waters where it's really difficult to see. Is there anything you want to translate of the things I have been saying now, Daniel, or is it understandable?
I think it's understandable, but some maybe questions. Drodzy Państwo, tak jak Państwo widzieli, na razie oglądaliśmy sobie tylko obraz z kamery głównej z tym trybem mętnej wody również, co było doskonale widoczne, jak ten procesor NVIDIA jest w stanie odsiewać ten obraz i poprawiać jego jakość. Cały interfejs też, tak jak Państwo widzieli, jest dosyć przemyślany i logicznie poukładany. Mamy kilka miejsc, gdzie sterujemy dronem, wysokością kamery, wysokością poruszania się i wszystkimi instrumentami. Teraz mamy już też widoczny sonar na ekranie i to, co jest istotne, to też wprawne oko pewnie zauważyło, a to jeszcze nie padło. Kontroler, którym sterujemy dronem, jest to kontroler z Xboxa Series S bądź Series X i to jest celowy zabieg z dwóch prostych powodów. Po pierwsze, jeżeli ktoś gra w gry komputerowe, to łatwiej będzie mu się nauczyć na czymś, co już zna albo chociaż kojarzy, a po drugie, ten kontroler jest bardzo łatwo dostępny, nawet jeżeli go uszkodzimy, coś się z nim zadzieje. Większe markety z elektroniką użytkową od ręki są w stanie nam taki kontroler sprzedać. Okay, Peter, I think you can move on.
Very nice. So here we go. So I've also turned on the multi-beam, which we saw, the sonar, which is underneath of the ROV itself. And here we can see how much that actually helps us. So now I'm only at 20 meters of range. If I turn this off or make it small, even with the turbidity filter, we don't really see what is in front of us here. If I turn that off, it's practically impossible to see anything in front of you. It's just murky. So if I turn both of those on again, here we can see that at about 8 meters in front of me, there is a big object. That's a very clear mark and a big shadow in front of us. So if I move over to that, without really looking at the camera at all, I can just move over here. And we can see there's actually a big mooring block on the bottom here. If I turn the turbidity filter off again, it makes it a lot harder to see. Turn it on, and you can see the difference there. And we can navigate over and see what is going on here. So again, on the sonar, it gives us a really nice visual of what is in front of us. We can see the hard edges of it. We can see the square shape. And we can even see the piece of pipe that is on top of it. You go closer to get a good look. And again, you can see how much the turbidity filter is helping here. We turn that off. On. What we can do is turn on the camera and move even closer to get some of the colors back as well. And here we actually see a crab is residing in the top here. Nice. And then if you go back to the multi-beam, turn up the range here. Let's do 30 meters, maybe 20 meters. And it's very easy to use this to navigate around. And here we can see something that looks like a tire or something. It's at least a round object, just 6 meters in front of us. Go over there. And here we see, yep, it was actually a tire on the seafloor here. Moving on. Here we can actually see a really big object that is about 20 meters out. We know this is a big object because it casts a big shadow. So it's you can think of it like shining a flashlight in front of you in a dark room and looking at it from above. So we go closer, zoom in a bit. And again, if I turn this off, can't see anything. We turn on the turbidity filter, still can't really see what is in front of us. Move over. Now we're just 10 meters out. And even now, it's difficult to see what is in front of us here. Turn on the turbidity filter, and now it's starting to be a little bit clearer what is in front of us here. So here we actually have a car that is sitting on the ocean floor. And with the turbidity filter, it's really easy to get good visuals of the whole unit. You can see it's been a while with all of the growth that has come on it. You can go closer. Get some detail shots here as well. Turn on the lights. Turn off the turbidity filter maybe. Go even closer. Take some pictures. You can move around here. We can see that the marine life has really adopted this structure. There's a lot of fish around it and other types of growth and shells and whatnot. Go in here.
Somebody asked the questions, can we read the vehicle identification number?
Might be difficult right now with all of the growth that has gotten on it. We have TDI here.
Yeah, so it's Volkswagen.
Yeah, it's Volkswagen, exactly. So if there was a number plate on it, we could probably read that as well, even though it's been a while. Here you can see the logo, Volkswagen logo. So yes, just moving about and getting some good visuals here. And if this was just gotten into the water, like in a search and rescue operation or something like that, then it's, of course, would have been much easier to get good images of any identification that you would need. Go in here and see that there is nobody inside of the car, and
it's blue, or some kinds of the shades of blue.
Oh yeah. And again, the difference between having the light on and just using the daylight here is quite striking. So nice. I think we're almost running out of time now. So if you guys want to do a question round, I can just hang out here in the background if you want to.
Okej. Więc drodzy Państwo, w międzyczasie zaczniemy sobie już przechodzić do sesji pytań i odpowiedzi. Jeżeli komuś się coś jeszcze nasunęło, to śmiało proszę pytać, a my sobie zaczniemy odpowiadać na te pierwsze pytania. So the first question is about the self-awareness in the water. How they get the position underwater?
Yeah, great question. And it's a little bit like I mentioned earlier here. Let's see if I have downloaded the map here. It's using the DVL underneath the ROV. So the DVL sends out acoustic waves And then it's using those acoustic waves to calculate how it's moving compared to the seafloor. So if you have no seafloor underneath of you, if you are outside of the range of the DVL, it's harder to get some really good estimations with the DVL. Of course, the DVL only knows that the ROV started here and then it's gone over here and over here. Now it's probably here, but it doesn't know where this is in a global context. So that's why we use the GPS on top of the ROV. When we put the GPS in the water, we get a starting point and then we continue from the DVL itself. Does that make sense?
Yes. Yeah. Czyli tłumacząc na nasz język, są dwa systemy, które ze sobą współgrają. Dron bazuje na module DVL, który za pomocą akustyki bada, co się dzieje w jego okolicach, ale też, żeby wiedział, na podstawie czego może sobie liczyć swoją lokalizację, to jest moduł GPS, który jest uruchamiany jeszcze przed zanurkowaniem i ściąga tą pozycję GPS-ową przed rozpoczęciem misji. Okay, next questions. Will it be possible to attach equipment for collecting water and sending samples?
Maybe you can answer that, Uda, what we have available right now.
Yeah. So with the ROVs today, you can connect different equipment. We have integrated tons of them already. Right now, it's possible to collect sediment samplers using the Newton grabber. It has the sediment sampler attachment. So that one is compatible with all ROVs. And then we have an in situ water sampler as well. So you can collect readings of different water quality parameters throughout a dive. And that's also compatible at least with both X3 and X7.
Okej, czyli jest taka możliwość do kolekcjonowania tych próbek za pomocą grippera z dodatkowym modułem. Is it possible to determine the underwater drone's geographic coordinates?
Yes, that is in regards to the position again, right? So where it is in the world. So with if you have a good GPS position and some nice tuned DVL data, then yes, then you can see where you are in the world. And as you can see here, I have a map. I have a map, and I can see where the ROV. Oh, sorry, I have a map here, and I can see where the ROV is and where it is moving.
Czyli jest taka możliwość, jeżeli mamy dostęp do sygnału GPS na wodzie. Has it been tested for use in underwater photogrammetry?
Yes, you can do some. You can take this one a lot.
Yeah, definitely. Like we have tested it for photogrammetry on a number of occasions, and we also have clients that has done that, and they have just been using the camera as well, not the stereo camera setup either. So it's just feeding tons of videos or images up to third-party software such as Reality Scan or Metashape, etc. Then you can create beautiful photogrammetry models. I'll post in the chat here as well, link to our Sketchfab page where you can actually see some of our photogrammetry models as well.
Czyli w skrócie jest taka możliwość i zaraz na czacie pojawi się też link, gdzie są przykładowe próbki, sample, jak wygląda taka fotogrammetria uzyskana z drona. Już się nawet link na samym dole pojawił. Thanks, Oda. And the next question is, what is the maximum range of the cable and maximum mass volume limit?
For the range of the cable, I think the longest one that we have tested with success is 500 to 700 meters. Of course, it also depends a bit on the payload that you would need to have on it. Depends how much data you're sending through the cable. But if you're sending just the normal data, so camera and whatnot, then you can do 500 meters, no problem. And if you really push it, then you can do 700 meters. But then again, you're having a lot of cable, so you would have a different reel than what we have here. You'd have different transport system and whatnot because it just adds a lot of mass. So we do recommend staying below 500 meters.
Czyli maksymalna możliwość to jest 700 metrów nawet, deklarowana taka, gdzie na pewno wszystko będzie ok, jest to 500, a wszystko też zależy od tego, jakie moduły payload do drona podwiesimy, w związku z tym, że rozchodzi się tutaj o transfer danych, zresztą tak samo jak w lokalnych sieciach przewodowych, po prostu im dłuższy ten kabel, tym mniejsza jest przepustowość i o to się rozchodzi. And Peter, what is the maximum volume or mass limit for the cable? It's 80 kilograms?
Yes, 80 kilograms. That is a breaking strength.
Masa własna. Is there an option to plan an automatic route similar to how flying drones operate?
To make like a planned mission, you mean?
Yes.
Yes, you can do that. That is built into the. Yes, you can do that in the Blueye Cloud if you want to, or you can even make that mission right here in the app if you want to. Then you could. I can make some points here, and I can tell the ROV to go to point of interest 2, go to point of interest 3, and go to point of interest 4. But it is of course easier to do that in the Blueye Cloud.
Czyli jest dwutorowe podejście. Odpowiedź oczywiście jest pozytywna. Docelowo przez chmurę Blueye najłatwiej to zrobić, jest najwięcej opcji, ale możemy to bezpośrednio z oprogramowania z kontrolera proste misje planować. Does the drone can work without GPS signal, or is it necessarily to pass some kind of self-test to use it?
No, you don't need the GPS. The GPS is only to help you find out where you are in the world to get you the geolocation. So you can, if you want, you can use the ROV with no external equipment at all, just a swimming camera, if you will.
Okay, and the last question for now. We have GPS position when drone is up the water, but under when we make mission, how drone knows the correct directions? This is because of the DVL, I think.
Yes, correct.
Czyli za pomocą modułu DVL, który bazuje na skanowaniu fal częstotliwości radiowych. Okay, I think we just go into the end of the sessions. We don't have more questions. We are on the time, only 60 minutes, like there needs to be, and they plan to be. Thank you very much, Blueye team, for presenting your solutions to Polish customers. Drodzy Państwo, bardzo dziękuję w imieniu swoim, Maćka, ale też organizatorów za to, że dołączyliście Państwo do tego spotkania, zadawaliście liczne pytania. There is the last questions. Do you have any waterproof controllers attached to the drones?
We have a weatherproof controller. So the one that I have here, which is the one with the built-in screen, that is our rugged controller that we sell. This is weatherproof, so I don't remember the exact IP rating, but it is dustproof, rainproof, but it's not submergible. You can't submerge this underwater, but you can easily use this in rain and whatnot.
Czyli jest kontroler, który jest odporny na warunki atmosferyczne, ale nie do takiego użytku, że my gdzieś koło drona możemy zanurkować i z nim dalej sterować. I ten kontroler jest oparty na Samsungu Galaxy Tab serii Active.
Tak, no z naszej strony jeszcze dziękujemy za Państwa obecność na pewno i zachęcamy, jeżeli są jeszcze jakieś pytania szersze, czy właśnie odnośnie cen, dostępności, to proszę nam zostawić kontakt do siebie i po prostu będziemy się w najbliższym czasie odzywać, kontaktować i odpowiadać na Państwa pytania.
Ja też przygotuję nagranie po tym webinarium. Prawdopodobnie jeszcze w dniu dzisiejszym dostaną Państwo mailing z podziękowaniem za uczestnictwo i tam też będzie kontakt do Maćka, z którym można się bezpośrednio kontaktować.
Zachęcam.
Szczegółowych informacji. Z tego miejsca dziękuję jeszcze raz bardzo. Życzę Państwu miłego dnia bądź popołudnia i mam nadzieję, że do zobaczenia na kolejnych webinariach, które niebawem będziemy planować.
Dziękuję.
Thank you, Blueye team. Goodbye. Have a great day.
Thank you.
Dziękuję.